Hi all. Sorry for being late, fighting with my computer. I hope you can hear me.
Yes, I can hear you. Hello.
Cool. Hi Santiago. Thanks a lot for joining. We've been looking for this for months. Like we were talking about in Toto in our past meetings, and I was like, how can I access Santiago? How can I reach to him? And then finally I asked Dan, like, can you, introduce me to you? And then he helped.
Yeah, no, he's very well connected. I think he knows everybody.
Yeah, I actually watched your talk. I think that was the first CDF event, like CD Continuous Delivery Day 2019.
Yeah.
With KubeCon. I think you presented in Toto there, if I am not mistaken.
Yeah. Feels like forever ago, but yeah, that's right.
It's like it's only 2 years, but yeah.
Yeah. So many things have changed since. But yeah, happy to be here. I hope some of it's going to feel a little repetitive if you watch that talk, but I wanted to cover essentially all the background around Toto, and then elaborate a little bit on what I think is relevant for the SIG Interoperability group.
Yeah, it's, as you said, like lots of things happened last 2 years. I probably have forgotten your talk, so
great.
Yeah.
Yeah, and a lot of things have happened since the Toto, so a lot of it is feels exciting.
Let me sending message to our Slack channel. Hi, Emil, Kara, Matthias, and hi, Venkat. Thanks for joining.
Hey, how are you doing?
Cool, good.
Hello.
So we made noise about this presentation, and and we normally had like maybe up to 10 people, regulars. Maybe they may join slowly. So let me try sharing my screen, and we start with the earlier agenda topics. And when we reach to your presentation, Santiago, others will hopefully have joined us. So today's agenda, it was kept short to give more time to in Toto presentation from you, Santiago, and then we can have an open conversation in Toto and how we can collaborate from CI/CD perspective. So the agenda is, as usual, we start with action items. Then we, as some reminder again, we changed the meeting time recently, and this is the new time, or the first meeting for new time after this summertime like thingy happened. And then, as you know, we started updating our SIG Interoperability roadmap because things have happened since we released the first version. And then we will move into the presentation. So we can look at action items perhaps. So the first action item was on Matti, who actually was one of the people who was talking about in Toto and showing interest, and I hope that he would be here with us because he was interested in Toto. I don't see him yet, but he may join on the way. And the next action item was on Tracy Miranda to find more about CISQ software bill of materials. I am not sure if you are engaged in that, Santiago, already.
I am.
Yeah, I think I remember. Yeah, yes, you are there as the third person. Maybe
yeah, I can fill you in too.
Yeah, ask your opinion about the CISQ, and then we close Tracy's action item. That could be a win-win. And then I have an additional topic or question about CISQ. I'm sure you all are aware of the formation of OpenSSF or launch of OpenSSF. Maybe you can share your opinion about OpenSSF, the CISQ, and the broader collaboration in software supply chain, where we should be looking, because things are a bit confusing, to be honest. So maybe
It's perfectly understandable.
Well, you want to take that topic
anything.
now? We can just talk about it now if you want.
Sure.
And you can, yeah.
So the CISQ software bill of materials project. This actually started with K. I always confuse K and Kate. Kay Williams from Microsoft.
So yeah.
So she, and this is almost a precursor of SCIM, which is I think now the like Microsoft endorsed approach to supply chain security. Essentially, it started as a project on trying to identify tool-to-tool software bill of materials exchanges. So how to have, say, a CI/CD pipeline share software bill of materials that can be passed forward to, say, a packaging infrastructure or a repository that's going to be delivering software. Now, my understanding is that this was an effort that started probably around 2019 or so. And since it has been essentially split and merged into other efforts. So a lot of the like SBOM bits merged with the SPDX community. So essentially how do we identify what are we going to be sharing and passing forward as SBOM information? Then that essentially meant they merged the community with SPDX. And then how to write tooling that can understand like SBOM semantics and like the tool-to-tool part of the Cisq was essentially moved over to what now is SCIM. It went a couple of hops between communities, but now it's SCIM. That's a supply chain integrity model, I think. That's what it stands for. I think it's on the GitHub repo on the GitHub organization for Microsoft. That's the one.
This is the one, yeah?
So okay. That's essentially the philosophical successor of what the Cisq what the Cisq wanted to do with the tool-to-tool. Part of it was because SPDX, in a sense, is starting to crystallize as the SBOM standard, especially now that they have this ISO. I don't know the correct term is certification, but it's now encoded as an ISO standard, right? So everybody can look at it and have some confidence that people will know what you're talking about. Now, part of the question around supply chain integrity in general becomes, well, how can you actually interpret this? How do you write policy? How can you know that you're getting the right SBOM from the right party? That's something that I'll dive a little bit on my talk. But that's essentially what happened to it. I wouldn't suggest looking too much there anymore. If you look at the list of people that you had there just a second ago, for example, Kay Williams, Microsoft, Bob Martin are now like on SCIM. My understanding is that Bill Curtis is also around all of these efforts. If you look at the rest of the people, most of them will be related to like ancillary projects that now essentially relate to either SPDX or SCIM or somewhere around there.
Okay, that's good to know. That I already captured. SPDX and okay, because like when I like everybody else, like when I put SBOM to Google, I get few hits, and this is one of those links. And now it is like, having some clarity about where to look is a good thing. But
it is an interesting space to be in because there's a lot of movement, mostly because there's so much there's so much need for it, but at the same time that makes it have a lot of entropy. So 2 years, and I think there's been 5-6 different names and affiliations to like the project, but it's a lot of the same people just identifying how to better leverage and grow a community.
Yeah. So thanks a lot for that, Santiago. We can tell Tracy she doesn't need to worry about her AP. And I just to make sure we are recording this, yeah, because I see red dot there. So because this is a good, good info. People can follow afterwards. So any questions about CISQ or other things Santiago highlighted? Okay, so moving on. So Matty to reach out to Kate Stewart, and Matty is not with us today, so we keep it open. And the next action item was on me, and I consider this as done, but to speak with Santiago. So that is kind of good thing to close action items. Yeah, the roadmap. So we started updating that and sent a notification to mail list, and unfortunately we haven't got too much input from community, but we will continue pushing that. So I keep it open for the time being, if it's okay with you, Kara, so we can work on it. Roadmap. Okay. What was the last? Okay. So yeah, us talking about what we are doing to end user council, if I understood correctly.
Yes, and okay. We're more than welcome to do so. The last end user council of the year is you, Fatih, presenting. So that is already booked, as you know. However, in the new year, absolutely. Okay. And it's really just when we're ready to do so.
Okay. But I keep this open so we don't forget about this after New Year, because now we are coming to Christmas, period and whatever. So it's, I keep it open. Cool. So we have 2 action items closed, which is good. And then we can move to the next topic, which is the reminder on the new meeting time. Again, like, I don't know if one of the reasons why we have so few in this meeting, I know this confusion, because this is the first meeting we are having after the summertime change, which always makes things kind of confusing. But yeah, it is the way it is today. So we meet 16 UTC until March or April. And then the next topic is SIG Interoperability Roadmap. So just opening that. And thanks, Kara, for going through the document and my comments there. And maybe we have Emil and Matthias here. So if you could look at my proposal about what to do with events, because events was one of the items under our roadmap, and now we have the SIG events in place and CD events creation in the pipeline. Maybe, as I recommended here, we drop that item from our roadmap as the thing we have done, and then we kind of refer to it as an item we should keep close collaboration with SIG events, so we don't completely drop it from our roadmap, but turn it to something that is driven by SIG events and CD events, and we need to keep that in mind when we work with these interoperability topics.
Yeah, that sounds perfectly reasonable, of course. Yeah.
Cool.
Yes.
So yeah, and obviously, since you are here, that is not limited to like please look at whatever comments there are and some updates, and add other items that comes to your mind. For example, this supply chain, we have it there, and then Ramin brought up policy-driven CD as well as a candidate top item. So if you have other things in your mind, that would be good to include in the roadmap for discussion as well. Anything else? Maybe Santiago, since you are kind of looking at things from a bit outside, like when you think about these CI/CD tools like orchestration tools or the pipelines themselves and interactions between the different phases within the pipelines, or the tools that are not traditionally seen as pipeline technologies, like what is your thinking? Because you mentioned a few things when you were talking about CISQ, like tool-to-tool exchange of S-bombs among pipelines, build tools, and so on. Do you have anything that is obvious to you, but we might have missed when it comes to interoperability?
Catches me a little bit off guard. I wasn't trying to think for that. I actually, from the document that I saw, something that I would like to hear about, or maybe see it described is, and apologies, I come from a security background, so maybe I take security like as a zero thing to think about. There was a mention of policy-driven, and then there was a mention of the security aspects of policy-driven. And part of and I'll talk a little bit about it on the in total talk, but part of what it in total, or generally a lot of the security tools are trying to do is turning questions of security into questions of compliance. So I am interested in hearing a little bit about what policy-driven CI or CDE really would mean for like the compliance angle and like the security aspect, or whether those are the exact same thing. It's just a matter of like, you have a security policy that goes beyond certain aspects of security.
Yeah, I think that, because like, okay, I think this is a topic we start talking about around end of 2020 or something. And since we look at things from CI/CD pipeline orchestrators or tooling perspective, our, how to say, maybe I shouldn't say our, but my focus or interest was more in how the interactions between different policy frameworks and orchestration tools could be achieved, like this open policy agent or something else coming from Rancher or Open Rancher. I think there are different policy frameworks, you know. Instead of talking too much about what kind of policies can be enforced, but how the interactions between policy frameworks and CI/CD pipelines and technologies could be simplified. Because like if you think this big scheme of things, like, okay, you have developers doing certain things and those developers perhaps know secure coding practices, for example, or they are aware of the dependencies they are including and they shouldn't include any outdated dependency with known vulnerabilities, and how the policy frameworks or policy engines could block things from progressing further within the pipelines if an outdated dependency is identified during like gating stage in the pipeline. So that is kind of pretty, like, developers are familiar with those things. And the other aspect we were talking about was, okay, the security aspects, in some cases, the developers may not be so familiar with those, like this GDPR, for example. Let's assume you have a feature in your product and that feature requires access to some user data. And that is actually not allowed to be done in EU, for example, because GDPR, but developers may not be aware of this. And then policy framework should enable organization for such policies to be enforced depending on what region that product is rolled out. And those policies could and should perhaps be entered by the people who knows these things, not developers per se, but the people who actually know legal aspects. So that is another aspect we looked, and the other aspect could perhaps be sales aspects. Like, as a developer, I want my stuff to be in the production as fast as possible, but tomorrow is Black Friday, which is fine for me because I trust my thing works. But the sales organization may say, we trust you, but don't break our stuff just before Black Friday. So we block any deployments to production. And that could be enforced by, you know, policy frameworks, and how those interactions would happen between the orchestration tools and the policy framework. So it's like not focused on security, but security is one of the things that we discussed when it comes to policy enforcement, and we call our list under policy-driven CD.
I see.
But yeah, security is like one of the obvious and critical aspects on policy enforcement. Because we all come from, like, CDF has members from fintech or web scale, and they have different, you know, things they consider as important. Like if you look at telco, we have like yeah, we have overlapping concerns, but there are other concerns like telco industry might care, and we try to, you know, collect these things together and see, okay, how this can be achieved. So
Right, that does make sense.
but yeah, then you showing interest to policy-driven CD means like we have some meaningful thing in our roadmap, not focused on security itself, but actually enabling people to enforce security policies in a more simpler way, perhaps.
Yeah, and I think those will become a little bit more clear of where I'm coming from once I talk. Yeah, is this document something I could like comment on?
Yes, definitely.
Great.
It's, let me put the link to chat, and I think, yeah.
Oh, it is.
Yeah.
Yeah, I'd be happy to take a look at that.
Yeah, that would be great.
Maybe
Like,
learn something.
yeah, comment away. This, like, the document is like, we haven't updated it really. We just were looking what we should be updating. So this is pretty like almost same version as our current roadmap, and we are talking about what we should drop, what we should consider as done, and what we should be focusing in next year and in future. So anything you can put would be valuable.
Right.
Okay, so anything from you, Kara, Emil, Matthias, about roadmap before we move to in total presentation?
No, nothing from me.
Okay, then stage is all yours, Santiago. I stop sharing.
Okay. Let me give it a try. Okay, so do you see your document?
Yes.
Do you see my slides?
Yes.
Okay, so now I know your. Do you see my slides? Take two.
Yes.
Great, fantastic. Okay, so hello, I am going to be talking about in total. I hope I'm in the right room. This is the CDF SIG Interoperability call. I'll be talking a little bit of background first. I'll be sharing essentially how the problem came up to be. Maybe for us on the post-SolarWinds era, this is a little clearer, but I'll just try to build up into what essentially made in total exist. And then I wanted to talk a little bit about what I think may be the interesting bits of the whole in total community for like the SIG interoperability SIG inside of the CDF. So let's just get started. The way that I usually talk about software supply chains and then is first by starting with an actual supply chain and their compromises. How do they actually get hacked? Now, a concept that's very central, and this is probably familiar to you because you're working at CDF, you understand that eventually leading up to a delivery is important. Supply chains are characterized by their end product. This is what they're meant to be for. They are delivering a good or something to somebody. Now, to just make it a quick metaphor, a product could be a Tylenol bottle, could be something that you're taking for a headache. Now, to get this Tylenol bottle all the way to the hands of you or to a pharmacy or counter, it actually went through a series of processing steps in which they acquired source materials, raw materials like a paracetamol or whatever, and then they started packing it and transforming it and eventually putting it into a bottle and then sealing that bottle and then shipping it over to God knows where, so you can actually go to your local pharmacy and consume your Tylenol whenever you have a headache. Now, supply chain compromises are something that we are very, very naturally left to understand. Somebody can break into the physical supply chain and cause damage. I actually picked a model of Tylenol because there's a very, very gruesome historical event that happened in the 1980s where somebody walked into a pharmacy, opened a bunch of Tylenol bottles, and then sneaked cyanide on them, then put them back into the counter. And I think more than a couple dozen people died, which is incredibly sad. But this is the precedent that we have to actually many of the security properties we see in a Tylenol bottle. We, for example, have log numbers that can help us recall whenever we see a faulty product being shipped to users. We have an expiration date, so we know that we are getting something fresh, so it's not stale and it still works. We also have a tamper-proof seal. This is an actual direct consequence of the Tylenol murders, that now we have a way of knowing that the delivery pipeline from the pharmacy all the way back into the manufacturing facility that made the Tylenol didn't have any sort of tampering with the product that we're about to consume. Now, I'm going to step back and let's think about what can happen in the very, very similar way with the Chicago Tylenol murders in the software that we make every day. So this is a very cartoonish supply chain. Let's forget about the Tylenol. Let's forget about all of that. This is essentially what we may be doing on a side project or even on a more mature pipeline in which we take some source code. We may be putting it on GitHub or private source code hosting. We may have a testing pipeline that's branching out that essentially tells us whether they trust something. We may even include that into a build system or a more mature, like a pipeline manager like Tecton. So it's all abstracted out as a single step. It eventually may make it into a package repository so that users can go in the same way that they go to a pharmacy and they can consume, or in this case, a Debian package. So GitHub, Tecton, Debian package. Now, I want to be here telling you that all of this works very well and that nothing bad happens. Actually, attackers can break into the software supply chains in many, many various ways. This is an example that I really like bringing up. There was a hacker that broke into the version control system of the Juniper firewalls and changed the pseudo-random number generation routine in such a way that they could decrypt every single VPN traffic of this particular version of the Juniper firewalls. This was back in 2015. People even thought it was the NSA. It was that devastating that we were thinking about state agents causing this sort of damage. And of course, this is not trying to say that only Juniper gets hacked in the source code. There's been instances that date back all the way to 20 years back, causing a lot of different degrees of impact to everyday users. Of course, this is not isolated source code. Build systems have been hacked. An example that I like a lot is somebody made a malicious version of Xcode that eventually infected Angry Birds, and then Angry Birds was trying to steal people's credit cards all throughout the world. We didn't hear a lot about this because it was stealing Chinese credit cards, so it was a bigger buzz over there. But this is the impact, right? Suddenly, a single build of Angry Birds makes it into every single user of Angry Birds. Of course, again, this is not trying to say anything about Apple or anything about Angry Birds. It's just, it happens over and over and over. And well, we're programmers, we're good at interpolating. You wouldn't be surprised if I told you that, that hackers also break into the packaging infrastructure. We just had this recent discovery of a NPM flaw that allowed people to write packages into different registers. But one that I like to bring up is the phpMyAdmin package that was corrupted in only a mirror, in the South Korean mirror. The consequence of this is that the hackers were able to hack a particular population, in this case, South Korea. It doesn't take a lot of imagination to think that this is probably the North Korean government or any of the political enemies of South Korea trying to hack into the machines of the South Korean government. This, for example, happened with Operation Aurora, where people were targeting high-profile companies by targeting other high-profile companies. And of course, again, this is not trying to say this is exclusive to the South Korean example, but rather it just happens over and over again. And part of the reason why I was asking about compliance and security is because sometimes these things are very, very intertwined. You may have things that are not on the modification pipeline. Say, in this case, I drew the testing and essentially a compliance step as a fan out, as something that doesn't eventually make it into the product itself. But we introduce questions about compliance. An example that I like to bring up, and I don't know what my screen is doing, putting it all the way there. But back then, when Windows 7 was still a thing and Windows didn't need TPMs, it so happened that Windows 7 pushed out an update that bricked everybody's computers. Everybody that installed that update, their computer was fully bricked. People thought that it was actually an attack, the consequence of malware. Then Microsoft did a very thorough investigation internally, trying to identify what exactly will happen. And it just happened that whoever was supposed to be testing the patch for Windows 7 did not test the patch for Windows 7. Something about compliance becomes a highly impactful, essentially, software supply chain effect. And again, this is not to say that this only happens to Windows. This has happened to, and it happens widely in the open source world. I wouldn't be surprised if this happened to anybody out there in the industry. This is partly why we're trying to answer these questions now. So stopping for a bit, something that seemed a little bit too simplistic. I already showed you more than 30 different types of compromises on source code, build pipelines, packaging, testing. I took the liberty of drawing 8 different devils in which essentially things can go wrong. And I would wager that in 6 out of those 8, the system becomes fully compromised if anybody breaks into this. So, well, how do we fix this? Actually, I jumped a little bit. This is, of course, the stakes are high. We have now it's 2 years old. But back then, on like early 2020, before the election, people were starting to ask themselves, what are the consequences of the software supply chain in the upcoming presidential election? And this is not something about where you get the capacitors from. This is something about where do you get the software in where, well, democracy is starting to be at stake. And of course, well, not to say SolarWinds, the largest and most sophisticated cyber attacking ever, according to Brad Smith. And well, it's making nation states in like essentially highly sensitive situations to reconsider their cybersecurity. That's the stakes of software supply chain security. It's even got to the point that people are starting to think maybe we cannot build systems to solve the problem, but rather just turn into the insurers to assume the damage and try to recover from the loss. Now, let's think as technologists and let's try to fix this. Essentially, what we need to protect any chain is to first make strong links and then link them together. It is really not much more complicated than that. So we know that there's ways to build strong links. This is probably something that you're familiar with. You can use many cryptographic techniques to protect version control systems. This is actual work that I did back in 2015 to protect version control systems. You can sign commits, you can sign push certificates, you can do any sorts of different elegant ways to protect version control systems from hackers. You know that you can use different mechanisms, say a take-down pipeline manager to authenticate the workers, to make sure that everything is done correctly and that no hackers broke into the build system. And well, you can do the same in the packaging. You can do the same in the CI. So looking back at the image with 8 little devils, we can remove the devils that are standing on the step itself, in the links themselves. But we still have the question about, well, how do we know that things are passed to each other properly and that there's compliance and that there's a reasonable exchange of information between each other so that we know that things were followed to the letter and that everybody's behaving properly within the supply chain. This, again, it's nothing new. It's something that's very evocative. Well, that's why we hear bills of materials, right? When you get pieces from I don't know, from a vendor to build a car, then you make sure that they give you the right pieces and that the vendor didn't do anything wrong. And this is exactly what this is all about. So what we're going to be doing with Toto then is to leverage this existing strong links mechanism and then building an actual change. So to do that, we are going to, sorry for the academic diversion, we're going to build a system that allows us to have compromised resilience, essentially assume that some steps will be compromised. And then we're going to build a way to connect everything together by creating an all-encompassing system, an overlay that allows us to describe the whole supply chain, not only individual steps. And to top the challenge, we want to make it expressive enough so that we can describe every single supply chain. And I think this is going to be interesting especially for SIG interoperability, in which, well, we really want to make everything collaborate with each other in meaningful ways. So how do we do this? The first thing that we need to do is to identify the workers in a supply chain. We know that Bob will be doing the code, Carl will be doing the building, Aaron will be doing the packaging, and they will be doing the testing. We want Bob to be the only one that's doing the building, or Bob and his friends, and Carl to be the only one that's doing the building. Bob the coding, Carl the building. Apologies for that. So that, say, if we know that data is compromised, we have assurance that, well, the critical path wasn't compromised itself, and that we can still trust the final product. We can also recover from a compromise by doing this sort of role separation. We can say, hey, you know what, Dave, you're not doing things right. Let's bring Ada on board. Let's start trusting Ada. And then we recover from a partially compromised scenario to a fully trusted supply chain again. We also want to build a system that's tool agnostic. And again, I think this is very important for SIG interoperability, because we know that while a lot of people like to use Tecton, there's another CDF project that's also very widely popular, that's Jenkins. And we want to make sure that we can still describe these two supply chains between each other, and that we can still use the same semantics to describe the operations done by both of them, so that if we were able to ever to change a tool or just describe a different supply chain, we can use the same code, build, package semantics, or anything really that we want to do. This allows us to build an all-encompassing system. And I'm going to use a very silly metaphor, but just to drive the point home, we know that the supply chains of today are not supply chains of tomorrow. They may have different steps, different operations done into that. So imagine that tomorrow the Linux Foundation came up with a new sub-foundation that's the Authenticated Keystroke Foundation, and it's launched so that every single developer is authenticating every single keystroke on the source code that they're building. Well, we want to express ways to know that this is actually what's supposed to happen. We want to be able to make sure that the Authenticated Keystroke Foundation can communicate information to the source code and eventually communicate information to a build system. And imagine that somebody finds a way to essentially run over the whole Authenticated Keystroke Foundation and comes up with a hypno attack, so that this comes out in a new Vice article in 2022, so that people are tricked into writing malicious code. And that in order to protect that, we came up with ways to measure people's alpha waves and make sure that they're not hypnotized when they're writing code. Now, we want to be able to communicate that information forward as well, so that we know that people's intentions were right, that their keystrokes were correctly authenticated, and that they were passed into the source code properly, eventually to the build, eventually to the package, and so on and so forth. So by doing this, by having this sort of expressive tool-agnostic mechanism, we are able to represent all of the supply chains that are out there, not only the ones that are cloud native, not only the ones that are fully open source projects, but rather everything out there. This is part of a challenge that we faced as a total team, because we know that Debian packaging looks very different. It actually looks like a funny diverging graph as compared to Django, or as compared to Tails, which is an operating system image, or the Arch Linux ISO, or projects that only deliver source code like GCC, but they still make testing on their source code, or the Datadog pipeline that I'll talk in a little bit, in which they're using hardware tokens to authenticate every single line of code that the developers on the New York Times building where the Datadog offices are, and eventually make it to say, I think Twitter is still using Datadog, the Twitter infrastructure. So you know that there is a tamper-proof paper trail from the developers all the way to the infrastructure of all of these very, very solid for projects. So I'm going to explain a little bit of the architecture of how can we achieve this. This is going to perhaps not be very surprising to everybody. The idea is very simple. What we want to do is to verifiably define the steps on the software supply chain. Say this is what we expect to happen. Earlier in the meeting, we're talking about GDPR. Well, if somebody needs to check for GDPR compliance, we want to say, hey, there needs to be a step on the supply chain for GDPR compliance checks. Then we want to verifiably define the authorized actors. We know that certain actors are expected to perform certain operations, and we want them to do that operation and nobody else. And then we want to provide a tight binding of the artifacts as they flow through the chain. This is the build the chain part of the software supply chain. To do this, we first created a type of policy, and this can actually be transpiled to other projects. But the basic idea is that inside of this policy, you say exactly those things. These are the steps that need to happen. These are the people that need to carry those steps. This is the things that they're consuming and producing, and this is how it all connects to each other. With this, then you can start providing this artifact flow integrity property that is what we're trying to achieve on the software supply chain security world. We also allow project owners to authenticate this policy so that you know that the policy comes from an authorized party, say, I don't know, a BDFL on a project or the compliance manager inside of your company. They can create these policies and then make sure that they're followed to the letter. Now, this policy describes what needs to happen. So the other bit that we need to use is a way to track what happened so that we know that what happened is what needed to happen. This other bit is done with a type of metadata called a link, aptly named for the supply chain metaphor. And there's many tools, but perhaps the one that's the most agnostic is called In-Toto Run. You essentially run In-Toto and tell it, hey, do this thing and just make sure that you track everything that happened and eventually create this little, I don't know, my pointer is visible with this little attestation so that you know, well, whoever was in charge of developing source code is able to attest in a In-Toto link to what they did. Now, at the end, then it becomes an easy question. Do I have the final product, say my bottle of Tylenol or my Debian package? Do I have a policy that tells me how this should have been made? Imagine this like, again, a description of all of the supply chain. And eventually, do I have enough evidence to be sure that this was actually done how it was meant to be done? And if I have all of those things, then I can actually trust the product. If you're like into the academic bits of this becomes a question of graph isomorphism. Essentially, you treat the graph out of your policy, and then you try to match that graph with the graph that comes from the attestations. Now, I'm going to just quickly gloss over the security analysis. The basic idea is, well, you are able to say, I trust whoever told me this policy was performed, and then there's nothing that's either not done or done that shouldn't have been done. Then I know that the individuals that carry out the operations should be trusted or should be the ones that should be carrying out these operations. And then I know that nothing has been tampered in the way. Then I know that eventually the source code that went into my package is the one that's right. Now, something that makes me very happy as an academic, because this is not something we see a lot, is that we are actually very adopted widespread in different places. Most of it is through Datadog. Datadog did an integration in which essentially they authenticate every single change or every single plugin that they include into their agent by using In-Toto. This is what I was describing just a second ago. They have a very, very cool blog post about it, but essentially their CI/CD system plus their developers, they all create attestations of what they're doing, and then the agent, before installing any integration, any plugin, they go back and actually walk back the paper trail all the way to the developers that wrote the code. So they know that every single thing that they got comes from the right source code. It was written by developers in the Datadog office building using hardware tokens to authenticate every action. Now, this is all the background about In-Toto, essentially. And I wanted to contextualize this because we want to also be able to provide this information in a way that's easier to write policy around. So what we're trying to get at in the In-Toto community right now is to define what we call the lingua franca of In-Toto operations, essentially what is done in the supply chain and how is it usually done. And this is something that we're trying to gather input from different communities, say like the continuous integration community or the source code or say the service mesh community, right? The way that it used to be is that in total links were essentially 4 main fields. They were materials, things that were used, products, things that were produced, environment, where the thing was made, and byproducts, things that you don't want people to use, right? Things that you did, that created, but you don't want them to be used or passed forward. Now, this is a little problematic. We found out after a little bit of time, because sometimes there's quite a bit of overlap between these things. And also because it is not entirely clear to people what is a material sometimes and what is an environment, for example. Sometimes an environment can be a tool that you're using, or it can be thought of as a material, or a product could be something that's also changing the environment. So even though this allowed us a very agnostic, very opaque way of describing your operations and writing policy around it, the onus fell on the people that were verifying. And driving agreement between the ones that were creating the attestations, the total links, and the ones that were verifying them became harder to do. So what we're trying to do now is to provide a more expressive granularity, I call it. So the suppliers, people that generate evidence, can allow verifiers to know how to verify the evidence better. So suppliers can know how to properly fill all fields. They know what a material actually is. And verifiers can know what to expect in the materials field. And then suppliers can also extend, say they're using Tecton, and Tecton has its own specific semantics that are extending the regular CI operations, then you may want to append that to the existing in total links rather than just letting people figure it out. This also allows verifiers to say, write common policies. For example, we're talking about GDPR, then you could say, hey, I'm expecting a link that represents a GDPR check over my infrastructure. Or verifiers can also know, hey, this is a CI type. I may not know all of Tecton specifics, but I can verify it as a CI, as a archetype. To do this, this is something that actually was very inspired by JEPs and TEPs and PEPs and so on. We find this in total enhancements, IKs. In particular, the one that I think is of interest for SIG interoperability is the IKE6, which is essentially describing this way of creating generalized link formats. Right now, what we have is the CI provenance / salsa provenance type. This is actually something that can be used today with Tecton chains. This is something you can enable in Tecton. It starts creating a CI provenance type. You can also create in total attestations for speak text documents to essentially sign them, or you can fall back into the classic total link. Part of the goal of this is to allow, again, tools that are creating evidence of what they did being able to be consumed by tools further down the line or consumers to know how does this evidence look and how can I actually write policy around it. Again, the focus of this is to, rather than dictate how this should look like, is to drive it on a more community-based approach. You want to invite people from different communities to say, hey, this is what my tool does. Does it fall into any of the buckets that exist, or can I create my own bucket for them? And ideally, we'll then create this common archetypes for different types of things that you can do in the supply chain, but you can also transfer this information back into your community. So this is exactly what I think happened with a change provenance type, in which they said, hey, this is what change does. Then we discussed things around, and they were like, hey, this looks like what we want to do. Now we are encoding how this is done in the change world to create an in total provenance type as a TEP. And well, this is very useful because then verifiers, say Kyberno or Cosign or other SIG tools, can go and say, hey, I am expecting a CI attestation from Tecton chains, and I'm going to verify it to make sure that that individual step was done to the letter, and I can stitch it together with everything around its own supply chain elements. I wanted to keep some time for discussion, and I think we're running out of time. This is my information if you want to reach out to me. And yeah, I hope this was useful, and more than happy to field some questions now.
Oh, I have a few questions. I think I followed examples in your repo. I think it's Alice Bob, if I remember correctly. You had some example code and some, I don't exactly remember how was it, but I followed this, which is great. But then I started Googling, how can I, try this out more easily? Because, we doing things hands-on is one thing, to learn how it works, and getting things working in our software flows or pipelines is something else. And then I found since you talked about Tekton now, but I was looking for some other projects which in Toto is like could be used, and I found Jenkins plugin which you wrote a few years ago.
It is due a little bit of an update. I'll say that much.
Yeah, that was my question, Mike.
Yes, that's actually something that we are looking at in the near term. Let me pull up. So we actually rewrote the Java implementation to include this, the same as the Tekton chains predicate. This was merged very recently. It was a lot of work by this engineer at Google. Yeah, so this is the one. So now this is on the Java library, and the Jenkins plugin itself is an integration of this Java library. It essentially wraps it around. We now that this is merged, and again this was merged 15 days ago, we want to start updating the Jenkins plugin to allow you to create this sort of provenance. My hope is to again have this parity between, say, the Tekton chains project and the Jenkins plugin, so that both of them can create the same type of meta information. They may enrich it with their own semantics, but the overlay should be as common as possible, so that you can write policy around it in an agnostic way.
Yeah, because exactly the keyword, I think you mentioned this agnostic way during your presentation, is that because I want to give it a try and compare how this in total behaves, or what you get when you run something on Tekton and when you run something on Jenkins, and find similarities, because in the end we are talking about how the pipeline technologies we use could interact with frameworks like in Toto, and what could be how to say, let's say you want to change your orchestrator from A to B, but you don't want to lose everything you have done with your tool A when you move to tool B. So as little disruptive as possible, because in the end, you are orchestration some activities, and what orchestrates that is, yes, it is important, but what is important is the activity itself, running in Toto.
Right. Yeah, no, I that is my goal. I will say it's sometimes a little hard when it comes to, and this is why we have this escape hatch, because you will see that sometimes Tekton has its, I don't know, its own semantic, right? We have this thing that nobody else does, and this is our differentiator. Well, answer everything that that all tools need to answer, and then add your own special stuff. But if it is common, it's almost like there's a super class for all of them. If they all talk that language, then you should be not too troubled to change between them. And that is again my goal, and that's what we're trying to do in the community, to have this attestation. I should change the pinned ones. This attestation repository, in which essentially people can define different types of statements, or different types for, again, this provenance type would be very good for CI/CD systems, and all of them could produce essentially the same type. That is what I'm trying to field, to allow different projects to have, essentially this single source of truth, so they know how to communicate information to downstreams about what they're doing. Another project that you may be interested in looking at, it's BuilderDB. This is more on the open source community, but if you go to, say, this is rebuilding all of the Linux packages. Oh wait, this is not updated. This is another instance of the same. You can actually click on the little Untotal link and you get this provenance predicate. Again, this is important because then you may want to have agreement not only with this CI/CD pipeline managers, but with other projects that are like more on the open source community, Linux distro world style of things. And this becomes particularly important when you're starting to see that, say, these things are built and then stick into a Docker container that then used by a Tecton chains payload, right? You want to be able to walk all the way down and say, hey, are all of these dependencies built in a way that matches my policy? I don't know if you saw, that's why my backup slide is insecure totals all the way down, because you need to continue going down.
Yeah. I have one more question, but I want to give chance to others to ask as well if they have any. Okay, so my question is about something we discussed when you were talking about the CISQ, like an SPDX. You know, SPDX becoming an ISO standard in September or something made things interesting. And some communities already started adopting SPDX to generate SBOMs. And in perfect world, everybody generates SBOMs as part of their release process, and they dump them next to the other artifacts they are producing, like SHA-SAMs or actual tarbos or whatever. And that, I think that will, like, more communities will hopefully adopt that, making life of all of us better. So what is your opinion about something like in Toto attestation, like how you do this on Arch? By the way, thanks for Arch. I'm a fan of Arch Linux, but what is your thoughts on like something like this becoming mainstream and all the communities doing this, like built into their way of working? Like it's not like adding it after the fact, but building that right from the very beginning.
Right. So that is a big challenge, and that is also why I see in Toto and SPDX to be complementary. The way that I describe them is with the general SBOM notion is you get an artifact and then you just start digging and see what you find about it. Whereas within Toto, you just essentially carry forward information until somebody makes a determination about what it is. So it's almost like a disaggregated SBOM. Now, in an ideal world, I think that the Toto information would be useful for producing an SBOM at the point of release. You could say, hey, I have all of this evidence. I'm going to like start digging about it and eventually produce an SBOM that somebody can easily determine things about. My vision is that you will see a mix and match of both cases, depending on your use. And my hope is that you will actually be able to also secure SPDX documents within Toto as well, so that you can aggregate the SPDX documents in the same way that you aggregate different pieces of evidence. Because in reality, and this happens in Arch, right? Like not everybody does everything, and there is different sources of truth. I, for example, maintain the Docker image. The people that maintain the Docker image, they are a team of people that can attest for the state of the Docker image, but we heavily depend on other packagers for other parts of the distro, right? This is also why I want to allow for people to represent different operations within a chain rather than having this sort of big stamp process in which you finally roll out an SBOM. Again, I think both of them have their value, and I think they can help each other very well. I don't know if I went on a tangent.
Yeah, I think you respond to my question pretty well. So I really like, I have lots of questions and I will probably have even more, but I don't want to take even more of your time. So would that be okay? We like reach out to you on Slack or something, like when we continue our discussions within the SIG, or we do our own, continue trying in Toto and see how this fits into our workflows. So I hope you don't mind us coming to your way randomly.
No, I would love it. And actually, I feel that particularly the projects in the CDF are perhaps if we manage those, we'll be in a way better position, like supply chain security wise, than if we manage anything else. Perhaps the next big thing would be, say, GitHub or something like that, adopting it. But I see this, and this is why I wrote the Jenkins plugin back then. I was like, well, people are using Jenkins, and a way to generate evidence about this very, very mission critical step is so important.
Yeah.
So happy to help, and happy to also figure out ways to make things happen in a more seamless way. Also, like point people in the Toto community to like SIG interoperability here at the CDF, or just find synergies to make all of this happen. I think it's a good time to give this all a try.
So we are 2 minutes over time. So thanks a lot for this, Santiago. Really appreciate it. And yeah, we definitely continue talking, and we'll definitely disturb you coming days, weeks, months. And
happy to help.
With that, again, thanks, Kara, Matthias, and Emil, who left, for joining, and talk to you next time. Have a nice rest of the day. Thank you very much.
Thank you, Santiago.
Bye.